The burette was rinsed with water in solution 3 times each before use. First, we fill the burette with NaOH and release some into the waste beaker so that our initial value can be 0. So now Hazim's going to look at the meniscus, the bottom of the meniscus, to make sure that our initial volume of NaOH is 0, which it is. Now he's going to put 3 drops of phenolphthalein into our KHP acid. Then he's going to start titrating. You can titrate by releasing some NaOH into your acid quickly if you know your equivalence point. Once you start reaching your approximate equivalence point, start doing it drop-wise into the KHP acid. When you do this, make sure that you stir the whole time. And then you're going to start seeing little drops of pink form, but you can stir these drops out. However, when the pink stays, you need to stop titrating, and this is your equivalence point. You want a really, really light pink as your equivalence point. Such as this. Good job. Then you're going to measure your final volume by reading the bottom of the meniscus. Get on eye level. This is your final volume of NaOH. Record it in your lab notebook to 2 decimal places.
Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Now the first thing you gotta get straight in your head: acids turn blue, litmus paper to red. They react with metals with awesome power. They neutralize bases and taste very sour. Bases are different from acids, it's true. Bases turn red, litmus paper to blue. They neutralize acids, feel slippery on skin. They taste sort of bitter, and they're called alkaline. Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Well, there's even more to this wonderful tale, something we call a pH scale. It numbers from 0 up to 14. Those are powers of 10, if you know what I mean. When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way. Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Well, acids and bases, now why should you care? 'Cause acids and bases are everywhere. You put them on salads and they get in the rain. They settle your tummy and clean out your drain. So the next time you're sitting under some shade and you're sipping a glass full of real lemonade, you'll notice the sour taste and think in your head, I bet it turns blue litmus paper to red. Acids and bases have 2 different faces, 2 different personalities, and you gotta find out what they're all about if you wanna learn
chemistry. Titrations are performed to find the concentration of the unknown solution or analyte. We are also able to find the equivalence point by the indication of the change in color of a certain acid and base. Before beginning the titration, you need to know the composition of the standard or known solution. You need to have the accurate weight of the standard. You need to know that the standard can be heated the same every time. You also need to know the balanced acid-base reactions so that you can have the accurate mole ratios.
Then you find the moles from the mass using molar mass or molarity equation of the standard. Then multiply the moles of the standard by the molar ratio to get moles of the analyte. Then divide by the volume titrated to get the concentration of the analyte. To read volume, look at the bottom of the meniscus at eye level. Record it to 2 decimal places because the titration burette has a second digit after the decimal place as uncertain.